Greetings. Well, some people say, well, why did I have to build a dome? Well, years ago, in 1988, 4 amateurs were conned in to buying an observatory in the Cederberg. There was an old dome which was closed with masonite, and there was a little shed. And that was all we had, and a plot and a couple of foundations. Over the years, we did a couple of jobs to it, and we then built a second building, which now has a kitchen, 4 beds, dining room, and then we later on we've done more. But we still just had the little shed and the dome, but now you can see the dome has shutters. We also have a couple of piers there. You can see one there, one there, one there. And these were put up by Peter Mack for Halley's Comet in 1986. It's a lovely location, and quite often it's clouded all around, and above the observatory we have a big open space because the weather comes over the mountains, it dissipates like a tablecloth on Table Mountain, goes along the bottom of the valley, back up, and reforms on the other side, on the Wolfberg Mountains. At that stage, I started building my first equatorial mount. It was designed for a 8-inch Schmidt-Cassegrain, and it was designed and built from scratch. Everything built at home, including the pinion and the worm. Then we built a pier for it. This guy Wayne, he's still a member of the Cederberg, and he would run around like this in midwinter. At -2 degrees, he's running around. All he needs to keep going is a can of baked beans and a spoonful of butter, put it in the microwave or heat it up quickly, and that's his sustenance. He's still like that. There was my Celestron. Let's just move the arrow. There was my Celestron on the mount. It worked very well, but I didn't like it as a telescope to photograph with. I felt it was a bit too long a focal length for the accuracy of the mount. So what I did, I built another telescope. That telescope is there. It never ever, no one ever looked through it. When I took it away, I broke it up and gave the mirror to someone. But that only had an old cookbook CCD camera on it. And it was one of the first, you can't say mass-produced, but one of the first popular little cameras that an amateur could make. And it was part of Richard Berry's legacy to astronomy. Next to it, you can see the bucket. This bucket has water, and the water is piped up to the CCD in pipes, and it is used to take away the heat from the Peltier cooler, which is used to take the chip down to 30 degrees minus 30 degrees ambient. In midwinter, when it is freezing, and you're sitting outside, inside a sleeping bag, and the water is dribbling the whole time, there's only one thing you want to do. So many times in midwinter, you had to break off the observation or break off the photography, go to the loo and come back, get yourself into your warm clothes and carry on. I got used to it. I mean, that was in spring. In winter, it was much worse. And that is a legacy of Peter Mack, that big box. That was part of a big dobby he had for Halley's Comet. But often I would be in a sleeping bag on that chair. I often threatened to get inside the box. You can see that camera and that telescope quite nicely. It was our contribution to imaging only. So at that stage, we had, there was a telescope that had gone up. It was quite famous, went up into space. So we called this the Humble Telescope. Later on, we wanted to move the benches to the south side of the observatory. And so the farmer, who does a lot of building for us now because he doesn't trust our building methods, he built a new screen, which he's taken up another 4 layers since. And he built a foundation around my telescope, which wasn't square. It was 3.5 by 3 meters. So that was a problem for me. So now I had to round the rectangle. Also, you can see how low the door is going to be. everyone said, why don't you build it so the door, another couple of layers, so you don't have to really get down to go through the door. However, with the door at that height, with a big telescope, I can get within 5 degrees of the whole horizon. If it had been any higher, I would have lost quite a bit of my horizon. Is that okay? I was going to build a runoff roof, and 2 of the girls at the observatory said, don't be a ninny. Why runoff roof? If you're going to try and get protection, you roll the roof off and sit outside like you used to. Do you want that? You know, it made sense. So one of the girls gave me this little thing. She gave them out at Christmas, and she said, why don't you build a dome shaped like that? And that got me thinking about the geodesic side of it. And a couple of plans later, I'd been working with cardboard and that, and just starting to get a thought going. The right-hand side is nearly what it is, except it doesn't taper in. And again, the shutters don't curve nicely down. They're just a big L, which goes into the shape of the new shape, the new type of dome. So I went home and I started cutting wood. I had to cut these. These are 50 by 150, 2 inches by 6, the big slabs going right round, and those we're going to house or have a whole lot of triangles on top of them. So this was just a cutting program to see how much wood I would waste and how many of these pieces I had to have. And that saw still hasn't worn out, but my knees did. I had to cut 63 of those sections. So now you can see some of the sections on that original octagon. And you had to have 2 layers at the bottom and then 3 layers at the top. The 2 layers at the bottom are for the foundation, and the 3 on the top are going to be part of the rotating shutter. Here you can see some of the close-up. Never get any of the joins in the same place. Then I built a full mock-up of the site's profile on the garage floor or the carport floor, so that I could lay this whole thing out, and at any time I could go and have a reference and go and measure, because the whole thing was cut at home and then it was taken 250 kilometers up to the Cedarburg Observatory in the back or the front or both of my Opel Astra. That Astra is still going. My wife won't let me get another car because she said, this car has been so wrecked and shaken to pieces. Why do you get another car just to shake it to pieces? So she said, it's first of all got to fall to pieces and then you can get another car. A little thing I did here, I laid part of it out again and then I sprayed around. So then you got an illustration of where the round sections had to go on top of the octagon. There's some of the plans now for laying out the triangles. This was going to be the shutter area here, and it worked out quite well, except I think somewhere one of the triangles is wrong, but never mind, it works. What I tried to do, I build one piece, then I think, and then I build the next piece so it fits. I'm not the sort of person who likes to design a thing and get everything going from the start. I like to do it in stages, and quite often that means that you change plans in midstream. Here was the sort of final design. You can see here that on the outsides there's an overhang because it's 3 meters and the length is 3.5 meters. So we've got 250 millimeters wings on each side. You can see IBR like that. And I have 3 rails, which you'll see later on. Here is the shutter aperture. And there is the shutter aperture in profile. These pieces again, all cut in Cape Town and taken up and assembled. You see a lot of this. This is that old mounting that you saw me next to earlier on, taking pictures. Well, that became my workbench for the whole of this procedure. And anything that I did, I put the 8 sides down, and then I had to cover it and then go back to Cape Town and wait for the next month when I came up, because I used to go up, still go up once a month. The next time, here we go, now we're starting to put the circles on the octagon. And eventually when we put the wheels on, none of the wheels go on any of the sections of the octagon which are floating. They all go on parts which are supported directly by the walls. Here is a compass. There is a close range. You had that in the center, perfect center of the dome, and you just walked around. And what I did, I just poured resin underneath these, lay them out, nudged them until they were perfect, then left them. And just after about half an hour, just as the resin was starting to gel, I'd get a bolt and put it right through into the octagon below. So now we have the basic ring on the octagon, on the rectangle. There's a couple of shots just to bore you. Sorry. At that stage, we had to go down to Cape Town again, and this was one of the biggest jobs. I had to get delivered to a Cape Town, to a PAL firm, a 10.5 meter strip of 50 by 50 angle iron. And then at this firm, rolled it into a perfect circle. By the time I got it up, it was about 3 millimeters out, which was pretty good. Where it was out, you had to bend it. And you can't just bend it. So what you've got to do is you've got to cut it and bolt it and then bend it slightly to get it exactly right. And it was actually, it wasn't, sorry, as a rail, it was taken up in 4 pieces. So it went from the passenger footwell of my Astra round into the corner of the boot. There was about 10 millimeters to spare. So those 4 pieces were eventually put in place and then welded. Then at that stage, I also put on top the new, I put it on top of the wheels. The wheels were put in, this is 50 by 25 square section stainless steel. These are V-belt pulleys supported by 6 millimeter bolts with a bore race. And here, these 6 millimeter holes were driven right down through the 3 layers and into the octagon. Then you got this 8 millimeter thing, slightly sharpened. You put 2 bolts, locked 2 bolts on the end, and then just drilled it in. But before you drilled it in, just fill it with fiberglass for polyester resin. One of them have moved in the 4 years, 5 years it's been up. There you can see someone then turned up the whole thing, turned it over, and there it is. At this side here, you've got a little slit here, so you can move each wheel in and out slightly. You can move it up and down by those 2 lock nuts. That's a close-up. And it works very well. You can move the whole shutter with your little finger. Well, I wouldn't recommend it. You'll probably break it, but still, it's very light and very easy to manipulate. So there we have the foundation for the dome. Your octagon, your circle, your wheels, and now the circle upon which your triangles are going to be put to make the dome. So that was a rough diagram for the triangles. Some of them have got intermediate vertical strips and some of them don't. That you've seen. And there was the start of putting the triangles onto that. Masonite with the shiny side in. more of them going up, and testing a month later, testing the profile of the shutter gap. That was actually quite hairy, particularly at this point. You can see it's only supported by a tiny bit of about 10 millimeter rebar. But I just wanted to see what it looked like. And this was the first stage now. Now comes the hard side, because this piece of masonite is fine, but this piece has got to be carved back, because now everything is leaning slightly back, except for that part. But this part here, if you can see how it appears to lean back. So you've got to do you've got to get a plane and make an angle on each of these halves for the next lot of masonite to go on. Now, this just shows you, I think this is one that shows you what can be done with Paint Shop Pro or any of the paint things. If you see this little piece here, I'm going to try and put it inside the dome, but I was originally going to have a dome with one shutter, one big shutter. So, see? And the one big shutter became a problem, because it would have had to be anchored there and anchored further out. So I thought, no. And the other thing is, it would be a big sail, so the wind would take it in one direction. So I thought, no, I'll go to 2. That's left now for another month. Go home, do some more work, cut some more triangles, and then start assembling the top ones. You can see actually how they are angled back, and they've got to be put on the flat surface. So that's why I was saying the compound angles of the triangles of the second row, the upside down triangles. Nearly finished the first row. Right. Here you can see the first row is finished. All there is now is a gap there to be filled in. And then these 2 struts have to be put in. These 2 struts attach to a cross strut, and those cross struts attach to the format, to the shutter format. There you can see the cross struts. Now, also filling the gap between the 2 pieces of masonite. At home I use a very good filler made of polyester resin and plaster of Paris. It's brilliant. It's like hard putty, and then, well, or soft putty. But the problem with it here is that when it's at an angle, it starts running. So you end up with an empty blob here, and you've got a great big blob down at the bottom. So I thought, how can I stop it running? I can't start making new types of glue. So then I looked at my feet. There's plenty of sand here. So I mixed a little bit of sand with it. And the sand stopped it running, because the sand grains actually held each other in place on that slope. So now you have the shutter profile in place on those 2 side things going down there. There you can see now. There, down to there. And all that remains in the second row of triangles is this corner bit on each side. Right, now we're starting to fill in here, and we continue to fill in, and now we've got the whole top filled in. That area now is ready to be sealed, and it was sealed with polyester resin and strand chopped matte fiberglass. You can see it there. There we are. Now it's got its coating on. And that coating is very hard. Haven't had a leak in the building, and highly successful. Bandage it up, go back to Cape Town, come back up a couple of weeks later. But now we start talking. My dome has 3 rails. And someone said, you can't have 3 rails in the dome because it'll go across the gap. But no, I did not put my rails across the gap. I put the rails on the shutters and the wheels on the edge of the gap. So this here is round section, which is the shutter base. That's round section. This here is a set of pulleys, the same pulleys as used to carry the dome around. And they're set in such a way that the square section here, square section steel pipe, runs between them. Here it is as manufactured at home. You can see these run up and down very smoothly. It's only 2.5 millimeters, this, but this bend gives it an enormous amount of strength. And the bend is carried nearly to the bottom, but not quite. It's been slightly removed there so that the wheels have a free axis to turn. But that right angle bend strengthens it considerably. So there was the first part of the shutter put on. There was U sections of steel, and then it was welded and riveted to that U section of steel. And as you can see here, there is the shutter, the profile on which the IBR is going to be, and here is the rail. There's the center one. How is it joined together? Just put a square on the end there, and this goes round and it clips on with a bolt, and then a 6 millimeter bolt through that. Can you hear me at the back? Okay, thank you. So there's the shutter assembly in its easy state, showing it you opened and closed. Again, you can open it like that. And if we just go back, on the inside, you can see this bolt here. Now the lock is just a plate of iron. It's been bolted loosely into place, and when the other one comes towards it, you pinch them together hard and just slide. There's another hole, you slide it over the other one, just put a bolt, put a nut on part of the way, and it locks perfectly. Right, so there we have the shutters, and there's one more thing to do, and that is we've got to actually reinforce this now up at the top. In reinforcing it, we have to use cross members, diagonal members. Here we are. You can see the diagonal members there. Yeah, come back. You can see the diagonal members there. Now that whole thing, each shutter is very, very strong, and as you move it in or out, it stays in the same place the whole time. It doesn't rock forward, doesn't rock back. They all support each other because they're supporting it, one at that angle, one at that angle, and one at a slightly different angle. There's the first lot of IBR put on. It's very simple, and up here, you can't see it on this picture, there's a piece of polycarbonate IBR which has been cut and bent to the angle, and it's only about 50 millimeters, 60 millimeters, but it covers the curve. So you've got a perfect waterproof seal. And that area is filled pretty well with silicone rubber. There you can just see the green of the polycarbonate sealer. And there is the thing with the dome with its shutters closed and opened. Now, it's quite a nice shot. That's the highest point in the Cederberg. That's 2016 meters. That's Snuberg. and another shot of it. Now, just going back to putting the IBR on, how to attach it? Well, in certain places I pop rivet it straight onto the round metal frame, but in other instances I pop riveted a piece. This is actually circular, sorry, this is 20mm circular pipe, a 10mm section with a hole drilled in it, and then it's pop riveted to the top of the IBR, and it's held down by cable ties. 2 cable ties for each loop, so you've got built-in redundancy. Now, I haven't had one go yet. All the cable ties are still there. You can see them up there, see them inside. So that worked very well. Next thing, we had to cast a floor. Put a bench in, and there it is. The computer there is driving on Scope, the old program of Mel Bartel's. You can see that same old stand still there. It's a 93, so it's 20 years old, 21 years old. There's me with my dome. Someone said, why do you put a stone on the roof? Well, it's not actually, it's just in the background. But very satisfied with it. That's a 12-inch cuss, Naismith cuss. You can see the focus is up here. One of the guys said, if you put a long cardboard tube facing out there, it'd be just like the top of a tank. It's truly. So they wanted to call it the tank, so I said, you call it what you like, it's my dome. There's me and my dome before it was painted. Here's, so it's been painted now. Here is my cuss. You can collimate from the eyepiece. Here are 3 rods which go up to this circle, yeah? 1, 2, and 3. And if you turn those rods, you're pushing the circle out or in, or whichever way you want. If you want to change the focus in, you turn it 3 times, 3 times, 3 times, and you'll go in 3 millimeters, because it's a 6mm threaded rod that it works on. As you can see, my secondary scopes, I tend to use bungee cord. We have my camera there. This is a 150mm lens with a real piece of high tech. I'll tell you that in a second. Here is a flat field screen, which you can just turn the telescope around, aim at it, and you can get a flat field for imaging. Flat field is something which takes away any irregularities in background or in irregularities left by dust motes and such on the lenses. Now for the dark, this is a dark frame acquisition device. It's actually a baked beam tin which sits on top of the lens when you want to take a dark frame. Works well. Here's a drive, which is, since this has got another wire now going to it. Here's your drive board, and here are the relays to change the speed. You can see the relays there, and you've got 4 pots, 1 meg, 500 Ks, 1000 Ks, and 50 Ks. So you can do a very, very fine calibration. Just running on tip 120s and a stepper motor, a 4017 divider, and a 555 timer. And now I'm coupling this whole lot up to a computer, which when you get a drive, when you get a guide scope and you're driving, that guide scope will give an image to the computer, and on the computer, as the image travels slightly, it will vary the speed of this motor very slightly, very short periods, and it will pull the telescope back into the correct place. That's the next stage up. This is a 120 gearbox which was attached to an electric motor which burnt out, so I still kept the armature, just put another bearing there, and this is a super gearbox. So I've got about 3 to 1, 120 to 1, then with a step belt, 20 to 32, and then the main gear 120 to 1. So 120 to 1, 3 to 1, 120 to 1, and 20 to 32. So those give me my drive speeds. At the back, there's a clutch. It's just an offset cam. If you push it, it loosens the whole assembly. You pull it, it just tightens it all up. So you can put it on half and you can just turn the telescope wherever you are and leave it there. Only if you want to take a long image or something, you might want to lock it a bit tighter. Inside the dome, at certain parts, you can put pieces of wood across the triangles so you can have book racks. This was actually taken before, when I had a couple of computers in there. I have 3. If we go back, this computer, there's a drive computer behind me. This computer does my imaging and carries my music. There's a subwoofer. There's the one speaker and the other speakers on the other side. I got fantastic sound. The first images that were taken with this was of the moon through the big CAS. Hadn't been collimated or anything. We just took an image. And we took another image, and we took a third image, and we put them all together. And that gave us quite a nice terminator. I very seldom can have any happier moments than sitting in that dome, listening to my favorite music, hearing the camera click maybe every 2 minutes, look out of the shutter, say last time was at the tail of the scorpion, framed in the shutter, beer in my hand, paradise. Was it worth it? Yes. Would I do it again? You betcha. Thank you.
Thank you.
Any questions? Yeah.
We've got a few minutes. Any questions for Chris?
Yes.
Melvin.
What did you seal the bottom edge of the dome with? Or how did you do it?
Okay. You have a skirt. You had on the bottom. You built a skirt up out of masonite, fiberglass and resin, and on the top, on the edge of the top turning piece, you have the skirt coming down on the outside. So geckos can climb in and out, but no wind comes in and out, and that's the important thing. And no rain comes in and out. The only moisture I get in there is sometimes you get condensation from the roof falling, but very seldom.
So what did you do? What did you coat the outside with? Was it fiberglass?
It's fiberglass, chop mat, on top of masonite, on top of the rough surface of masonite,
Yeah,
then covered with the aluminium bitumen paint.
Oh, okay, aluminium bitumen.
Now that's a marvelous paint because as you paint it, it's all black. Then suddenly all the aluminium pieces line up and flatten and seal off. You wanted to ask?
Cost. What did it cost?
Cost. Cost 6,000 rand. It's not bad. Because if you take the cost of some of the domes that you could get from America, it would be 10 times that.
I had somebody contact me last week. He's got a 3-meter circular dome that he imported. He wants to know if we can advertise it. He bought it for 190,000 rand. He's hoping for 190,000 rand. So there's the comparison.
Cost?
Sure. How long, Chris?
7 months.
7 months, but that's weekends, 1 weekend.
That's weekends, but remember that everything was prepared at home.
Yeah.
So the weekend was. Just work. And a couple of times my wife and I would go out for 4 or 5 days during the week. So that
if you
helped.
came up to us for 2 months, you had enough time, huh?